Hello everybody, I'm Suman Matthews and today we will be discussing the topic on exact differential equations. This is a part of engineering maths. This video is useful for engineering math students, and for more videos you can click on my page or subscribe to my channel and playlist for more videos. Here we discuss what are exact differential equations and how to solve it, and how to convert equations which are not exact into an exact form and solve it. So, given a differential equation mxy dx plus nxy dy equal to 0, the equation is exact if partial derivative of m with respect to y equal to partial derivative of n with respect to x. So when is it exact? If partial derivative of m with respect to y equal to partial derivative of n with respect to x. And the solution is given by integral m dx plus integral ny dy equal to c, where ny is the term in n not containing x. So for integrating m we take all the terms in n, and for integrating n we take only the terms in y. Coming to questions. Solve 5x raised to 4 plus 3x squared y squared minus 2xy cubed dx plus 2x cubed y minus 3x squared y squared minus 5y raised to 4 dy equal to 0. So m is 5x raised to 4 plus 3x squared y squared minus 2xy cubed. Partial derivative of m with respect to y will be 6x squared y minus 6xy squared. N is 2x cubed y minus 3x squared y squared minus 5y raised to 4. Partial derivative of n with respect to x is 6x squared y minus 6xy squared. So what do we find out from 1 and 2? That partial derivative of n with respect to y equal to partial derivative of n with respect to x. So the equation is exact, and the solution is, this is integral m dx plus this is a term in n which contains only y, that is minus 5y raised to 4 dy. So when we integrate, we get x raised to 5 plus x cubed y squared minus x squared y cubed minus y raised to 5 plus c equal to 0, which is the general solution. The next question. Solve y e raised to xy dx plus x e raised to xy plus 2y dy equal to 0. So m is y e raised to xy. Partial derivative of m with respect to y is e raised to xy plus y. E raised to xy, we apply the product rule. So y e raised to xy, derivative of xy with respect to y is x. So this is e raised to xy plus xy e raised to xy. N is x e raised to xy plus 2y. So what is partial derivative of n with respect to x? We apply the product rule here. E raised to xy plus x e raised to xy into derivative of xy with respect to x, which is y. So what can we say from 1 and 2? That partial derivative of m with respect to y equal to partial derivative of n with respect to x. So your equation is exact, and the solution is integral. This is m dx, y e raised to xy dx. This is a term in n not containing x, so it is integral 2y dy. So this will give you y e raised to xy by y plus y squared equal to c, or e raised to xy plus y squared equal to c is the general solution. Now, if an equation is not exact, if partial derivative of m with respect to y is not equal to partial derivative of n with respect to x, we calculate the difference, that is partial derivative of m with respect to y minus del n by del x. So if 1 by n del m by del y minus del n by del x is fx, we take the integrating factor as e raised to integral fx dx, and we multiply the differential equation by the integrating factor. What happens if 1 by m del m by del y minus del n by del x is gy? Then we take the integrating factor as e raised to minus integral gy dy. And the differential equations becomes exact when it is multiplied by the integrating factor. So we see this problem: solve y into 2x minus y plus 1 dx plus x into 3x minus 4y plus 3 dy equal to 0. So your m is 2xy minus y squared plus y. Del m by del y is 2x minus 2y plus 1. N is 3x squared minus 4xy plus 3x. What is del n by del x? 6x minus 4y plus 3. So you can see that this is not exact. And del m by del y minus del n by del x is minus 4x plus 2y plus 2. So 1 by m of that will be minus 2 into 2x minus y plus 1. We take out the 2 by y into 2x minus y plus 1, which is your m. So this is minus 2 by y, which is a function in y. So what is your integrating factor? E raised to minus integral gy dy. That is e raised to integral 2 by y dy. This is e raised to 2 log y, which is e raised to log y squared, that is y squared. So what do? We multiply the differential equation by y squared. So it becomes y cubed into 2x minus y plus 1 dx plus xy squared into 3x minus 4y plus 3 dy equal to 0. So your solution is integral m dx. There is no term in x in n, so it is plus 0 equal to c. So I get integral of 2x y cubed minus y raised to 4 plus y cubed dx equal to c, or x squared y raised to 4 minus x y raised to 4 plus xy cubed equal to c. Solve x squared plus y squared plus x dx plus xy dy equal to 0. M is x squared plus y squared plus x. So del m by del y is 2y. N is xy. Del n by del x is y. So del m by del y minus del n by del x is y. It is not exact. So if I divide 1 by n, del m by del y minus del n by del x, I get 1 by xy into x. This is 1 by x. And what is this? This is a function of x. So I call it fx. So your integrating factor is e raised to integral fx dx, that is integral 1 by x dx, which is e raised to log x, that is x. So you multiply the differential equation by the integrating factor. So I get x cubed plus xy squared plus x squared dx plus x squared y dy equal to 0. So your solution is integrate this with respect to x. And do we have a term independent of y of x here? No. So you get plus 0 equal to c, because ny is 0. So I get x raised to 4 by 4 plus x squared y squared by 2 plus x cubed by 3 equal to c is the general solution. Now, if m dx plus n dy equal to 0 is of the form y fxy dx plus x gxy dy equal to 0, then 1 by mx minus ny becomes an integrating factor, provided mx minus ny is not equal to 0. So if you can write the differential equation as y into a function in x and y plus x into a function in x and y, then you can apply this rule. So look at this problem. Solve y into 1 plus xy plus x squared y squared dx plus x into 1 minus xy plus x squared y squared dy equal to 0. This is of the form y into a function in xy plus x into a function in xy equal to 0. So if m is y plus xy squared plus x squared y cubed, partial derivative of m with respect to y will be 1 plus 2xy plus 3x squared y squared. If n is x minus x squared y plus x cubed y squared, partial derivative of n with respect to x is 1 minus 2xy plus 3x squared y squared. Is it exact? No. So mx minus ny will be xy plus x squared y squared plus x cubed y cubed minus xy minus x squared y squared plus x cubed y cubed, which is 2x squared y squared. And so we take 1 by 2x squared y squared as an integrating factor. So your equation becomes y by 2x squared y squared 1 plus xy plus x squared y squared dx plus x by 2x squared y squared into 1 minus xy plus x squared y squared dy equal to 0. So what do we get when we simplify and open the bracket? 1 by 2x squared y plus xy by 2x squared y plus x squared y squared by 2x squared y dx plus 1 by 2x squared xy squared minus xy by 2xy squared plus x squared y squared by 2xy squared dy equal to 0. Now, so you get 1 by 2x squared y plus 1 by 2x cancelling the common terms plus y by 2 plus 1 by 2xy squared. X and y gets cancelled, so minus 1 by 2y. X and y squared gets cancelled, so I get x by 2 dy equal to 0. Now please take a pen and paper and work along with me. So you can pause the video at each slide and then proceed. So your solution is, what is your solution? Integral m dx plus integral ny dy equal to 0. So you get integral 1 by 2x squared y plus 1 by 2x plus y by 2 dx, which is m, and your ny is just minus 1 by 2y dy equal to 0. So we get integrating with respect to x 1 by 2 x raised to minus 1 by minus 1 into 1 by y plus 1 by 2 integral of 1 by x is what? Log x plus xy by 2 minus 1 by 2 log y equal to c. So simplifying, we get minus 1 by 2 xy plus 1 by 2 log x by y plus xy by 2 equal to c, or multiplying throughout by 2 log x by y plus xy minus 1 by xy equal to c is the general solution. For more videos on engineering maths, you can go to my page and check out. So we have learned how to determine if a differential equation is exact and ways and methods of how to solve it. Also, we have learned how to convert a differential equation into an exact form and solve it. So do subscribe to my channel. Thank you.